Hello everyone. Can you guys hear me? Right, thank you. Just give me 1 second. All right, let's begin today's session. So I'm going to share my screen. Right? Hopefully you can see a blank screen here. All right, so let's start with the discussion. Before we start the discussion, let me introduce myself. Yeah, all right. So my name is Amit, right? And I've been in the industry for more than 20 years now. I've been working since before 2005. And my area of expertise has always been DevOps, right? So I've been working on various domains within DevOps. So cloud infrastructure, CI/CD, containerization, and everything around it, right? Version control system, configuration management, and things like that. Okay. So I've been working on this. I'm based out of Bangalore, if it makes any difference. But yeah, I'm based out of Bangalore. Today we are going to talk about Terraform modules. Okay. Terraform modules. Terraform modules is a concept used in Terraform for sharing the source code. Now, since we are talking about an intermediate topic of Terraform, it assumes that you already have some understanding of how Terraform works. Okay, so I'm not going to talk about Terraform in detail. Maybe I'll give you just an overview, and then we will see how Terraform modules work. Okay, so now let's start the session. All right, we are going to talk about Terraform modules today. Any questions we can take in between the discussion, and at the end of the discussion, I'll reserve like 5 to 6 minutes for answering your questions. So let's understand how Terraform works. A brief overview. Expectation is that you already know it. So Terraform is a configuration management tool which allows you to manage or provision or deprovision, um, change the configuration, which allows you to manage infrastructure components. Like if you need 10 virtual machines or 5 databases or 100 um, elastic load balancers on your cloud infrastructure, instead of creating them manually, you use Terraform to do them, right? Now, how do you do it? So to achieve that, what you do is you identify a machine. Let's call it as Terraform server, right? You identify a machine, any machine which can run Terraform commands. So you identify a machine, and on that machine, you install Terraform, right? You install Terraform application. And now what you do is you connect this Terraform with your cloud provider. Let's say we have AWS as our cloud provider. So we make a connection between Terraform and AWS. That is done using provider plugin, right? That is done using provider plugins. Now, next step is we write a Terraform manifest, right, which is nothing but Terraform configuration file. So we write our desires here. For example, I want 10 EC2 instances. I want 6 elastic load balancers. And in this 10 EC2 instances, I want 5 Ubuntu and I want 5 RHEL, whatever configurations you want, right? You can define in your manifest, feed this manifest to Terraform. Terraform will talk to AWS and get your infrastructure up and running, right? So if you write your desire in the manifest, feed it to Terraform, Terraform will connect to AWS and then realize your desires. So it will create, for example, EC2 instances, right? 10 EC2 instances, and it's going to create load balancers, right? Maybe 5 load balancers. So creation and management of infrastructure components as a piece of code, right? This is a piece of code. That is the use case for Terraform. Okay, now today's discussion is about modules. What is a module? So let's say you have a very complex use case of, let me give to you in another way. Let's say in your team, there are many teams. In your organization, there are many teams who are using Terraform to get their infrastructure, right? Each of the team is writing their own manifest. Each team is writing their own manifest, right? Now, in an organization, we may have some standards, some possibilities. For example, we want to ensure that whenever somebody is creating the infrastructure, they should only use, for example, uh, whenever they create an AWS EC2 instance, they should only use T2 micro, right? They always should have tag of names equal to, let's say, my org. So all the infrastructure that are created, for example, all EC2 instances should be based on T2 micro instance, should have this tag, should have AMI, which is a specific AMI ID. AMI is nothing but Amazon Machine Interface, which is nothing but a unique operating system image. Okay. Now, how will you enforce that? Because in the manifest, any developer can write any code. And they can choose not to use T2 micro, but they can choose something else. So then how do we enforce it? Now to enforce that, what we do is we can write this as a module. Okay. A module is nothing but a shareable and repeatable piece of code. That means you write once and other teams can share it, can use it. Okay. So now in this example here in the purple box, instead of writing their own manifest from scratch, what the teams can do is they can import this module, right? If there is somebody else writing a manifest, um, some other team which have their own Terraform, they're writing their manifest, they can also import this in their code. So when they import this, all the organizational policies, all the organization's restrictions will be applied to them, right? And then you can enforce whatever configurations you want onto these people who are writing the code. Okay, that's the discussion about today. Are you guys with me? I'm not able to. Give me a second. Right. Cool. You guys are with me, right? You guys understand what is the discussion about? Cool. Okay. So Let's talk about it. Um, so this is a use case of module. Now, let's talk about how a module is structured. Okay, structure of a module. When you write a module, you have to do two things. Okay, first is you define your resources. So in the resources, you can say, um, you can define your, let's say, AWS resource or an um, S3 bucket or whatever. First is that, and then you define your variables. Okay. For example, you can say, um, let's say count variable, count equal to 1, or you can say AMI equal to A, B, C, whatever is a valid AMI, right? And you use these variables in your resources, right? For example, you can say AWS resource, and in the resource, you can say count is equal to var.count. That means the count variable for this AWS resource, sorry, EC2 resource is equal to whatever is defined in this variable, right? And the AMI is equal to whatever variable uh, is defined here, whatever is the value of this variable that will be utilized here. So all the parameters which are required for a particular resource, you can get it as variables, right? Now, what is the benefit of using variables instead of hard coding resources here is when somebody, let's say this is the whole module, right? So this is our module. And when somebody else wants to use our module in their manifest, right? So somebody is writing their manifest and they want to use our module. They can simply say import module, and this directive will import all the resources from this module. And then when you import, you can set the value of variables to your own desires. So you can say when you do import module, this entire resource block of AWS EC2 instance is imported here. Okay. And then you can say, well, set AMI is equal to XYZ. So although this entire source code is imported here, but the value of AMI would be the value of variable. And we are overriding the value of variable, which is the default of ABC to XYZ. So now when this EC2 instance will be created, the count will be the default count, but the AMI will be whatever variable we are defining. Okay, so you can import all the resource blocks and you can customize them by passing your own variables. Right? Making sense? Okay. Now let's quickly see an example. I'm going to use my AWS lab to create one EC2 instance. right? And I'm also going to use my VS Code. Just give me a second. Right, so let's say this is my webinar folder for demo. I'm just firing up my lab. So what I'm going to do is I'm going to, so this is my webinar folder. Just going to close all other windows. And this is part of another demo that I was doing. And here I'm going to first write my, I'm going to create a new directory here. Okay. Let's call it as EC2 module. And in this, I'm going to create a TF file called resources.tf, and I'm going to create one resource. So I create AWS instance resource, and AMI is equal to, let's see, I can see from some other examples. AMI is this one. With my AMI, and I say instance type is equal to t2.micro. Right? And I also create a variable. In the variables, I say variable my AMI dash ID, and default is equal to this. Okay. So I create a variable called AMI dash ID, and in the resources, instead of AMI directly hard coding it, I'll say for AMI dash ID. So here I'm saying use the AMI ID as the variable AMI dash ID's value, and instance type should be t2.micro. This is my module. It has a list of resources and variables. Okay. Now I'm going to use this module in my project code. So let's say I'm creating a infrastructure for a project, right? The first thing is I'm going to write a code for provider, right? So something like this, you already know what this is about. If you already know Terraform, so I'll say I want to use the AWS provider to connect to AWS, and in the provider configuration, I'm going to specify the credentials. Okay, now these credentials I need from my lab account. So for now, I'm going to get rid of them and let me log into my account. Give me a second. I'm logging in on the other screen, but I'm going to share it with you very soon. Right, so this is my AWS account. Okay, it's a lab account. And I am going to create the access key and the secret key. Again, you should know what is AWS and how it works. And I'm assuming if you are here for learning Terraform, you would already be aware about it. So this is my access key, which I can use. And 7. And this is my secret key. Now, you must be thinking, well, why is Amit showing me his secret credentials? It's fine. This is a custom lab account that I have created, which has very limited permissions. And these access keys will be deleted after some time. And I will also be deleting them after the lab is done. Right? So I do this. And now quickly, I'm going to go to this directory and I'll say Terraform init. Okay, it is done. Now this module is already created. So I have created this module, which is in my same system, but in a different directory, right? Now my Terraform directory is ready. I want to create some project infrastructure. So what I'm going to do is, well, in the resources.tf, I will also say count equal to, not like this. First, I'll go to variables. I'll say how many AWS instances to be created. So the count is set to the value of the variable count. And the value of the variable count is right now 1. So what I'm going to do is I am simply in my, let's say, instances.tf code. I'm going to say module. Okay. And module is this module block is going to tell Terraform where should the module be picked up from. Right. So I say module, I say EC2 and the dash instances, and I will say path, sorry, source. And the source is, well, go to the above directory and use EC2 module. So this is my source of the module. This is my project infrastructure code. for Terraform. This is where I am defining my manifest. And in my manifest, I have provider information, which tells Terraform to use AWS provider. And then I have instances, which tells about just one thing: import the module EC2 instances, and the path is this. Okay. Now what's going to happen is, as soon as that use the module from this path, it's going to look for the any code that is available in this path. So this is the code that it finds. It finds the code for this resource, and it finds these variables. It's going to import everything into my local work area. So I say Terraform init. Now Terraform init command, all I did is a problem. I should not use that variable name. Instance count. I'm going to change it to instance count. Right. Okay, let's do it again. Terraform init. Right. So now when I did Terraform init, what I got was in the .terraform directory, it downloaded the module. So it copied the module and the information about the module. Like the module is here and it is at this particular path. So take everything, all the source code, which is in this path, which is here. Okay, so fine, everything is here. And now in my instances code, when I say Terraform plan, it's going to show me what resources it's going to create. So it tells me one resource will be created. Okay, and what is that resource? That is an EC2 instance, and AWS instance will be created. Because that's what the module code says. Right? Create this resource. So the count is 1. So create one EC2 instance with instance type T2 micro and AMI ID is equal to this. Now, when I import the module, I can also set the value of variables. For example, instance count is equal to 5. I say import this module, but rather than using the default value of this variable, which is 1 instance count, set the value to 5. Now, as soon as I say that, when I run Terraform plan again, Terraform is going to use this module, but set the variable values as I have defined here. So it's going to create 5 instances. So here you see 5, right? But I can say, can I override the instance type? Can I say set instance type to something else? I can't do that because it's not a variable. When I design the module, when I'm using this module, in the module, there is no variable defined as instance type. So I can't use it, right? But I can override this AMI ID. So while using the module, I can say AMI ID is equal to something. Am I making sense here? Another example could be, use case could be that we want to enforce that any EC2 instance that is created should be created in a specific VPC. Right? So I can say VPC is equal to A, B, C, whatever. So now when they import and in a module they create EC2 instance, they can't choose which VPC they want to use just because there is already a defined VPC. So they have to import this module, and in the module it says use this VPC. right? Cool. All right. Any questions till now? That's the basic module functionality. Any questions? Okay, no questions coming in as of now. All right. So now next is how do we, when we work with modules, right? In our this lab example, the module was right in our local system, local directory. So the module was just picked up from here. But if I have to share it with my entire team, I cannot keep it in my directory. So what should I do? Right? So the question comes, when you are importing a module, what are the possible source paths that you can give? Right now, it was a local path. What other thing can you give? Right? So that let's take a look at that. So I say Terraform modules. Right. So you can specify these kind of URLs for your module source. We have looked at local paths. Right. So we can give local path, which is the relative path. Um, yeah, and also wherever the module is, we can give this entire thing. Or we can pick up modules from Terraform registry. Now, what is Terraform registry? Terraform registry is like a marketplace for Terraform components, Terraform plugins. Right? So you can use providers from here. You can also upload your modules so that other people can use them. Right? So you can publish your provider your modules here, and many organizations can use it, or anyone can use it. For example, hopefully there is an for AWS. So there is a module for relational database here, right? If I open it, I can use it by giving, by importing the module like this. You can see here they have some documentation. So I can write module RDS. Source is just like this. So Terraform AWS module slash RDS slash AWS. So that means Terraform is going to recognize that this is a path for the registry and download it from here. Okay, and then use it. If you want to see the source code for this module, you can see the source code. There is a GitHub link here. This is the module, right? So you have modules, and inside that there is DB instance, and then there is main.tf. In main.tf, they have resources, right? So there's the resource to create a random ID. There's the resource to create AWS DB instance. Okay. And then there is a resource to, for example, creates CloudWatch log group, right? Create an IAM row. So everything will be done. There are some variables which can be included, but you can override them. And these are all variables created for that module. So if I have to use this module, I can just write this code. Let's just use it here in our code here. I will write this module block. I just copied here. It says module RDS. Source is this. This means Terraform registry path. And version is this one. So this version of the module. And when I say Terraform plan, it says module is not yet installed. I need to do Terraform init. Terraform init is going to download the information for this module and keep it locally. So when we say Terraform init, you see here, this module is downloaded fully. Here, downloaded completely. Right. And now I can say Terraform plan. It says required argument. The argument identifier is required. What does that mean, identifier? Let's see if this works. Right. So now we did a plan. It's going to create 6 resources. It's going to create a random ID. It's going to create a AWS instance and whatnot. But then it also requires these values. Okay, what should be the engine name? So this is a value that we need to provide this module. The module does not have any default value for this variable, looks like. Then major engine version, right? And family. So let's see if we can provide some of our own values. So I can say engine is equal to, let's say MySQL, right? And major engine version is equal to 5. And family is equal to some random words. So I can pass my own values. Let's say plan. So now it's going to create 8 resources with the values that I passed. And there is one more missing, which is instance class. Okay. Let's see, instance class is equal to, I don't know, I can just put something. Let's see if it is validated. I say gold. And now it's going to create 9 resources, right? So it took the default variable values for the other variables, but these 4 variables required explicit passing of values. So I passed them. If I go to the source code of this module, you can see there is a main.tf, and these are some local, and these are some other modules that are imported. But then there is variables. In the variables, there are a lot of things. For example, there's a variable called identifier, but there is no default value. So we had to pass the default value of the identifier, right? We had to define something because there is no default value. Same goes for engine. Right? Definitely, there is a variable called engine. Here you see engine, but there is no default. The default value is null here. So we need to define something. So we defined engine as MySQL. So like this is an example where you can use a module which was published by someone else, and we downloaded it from Terraform registry and then passed our own values. You can look at some examples. So most of the module developers also show examples. So if you see examples here, for example, if you want to deploy a MySQL, so you can say Terraform init and they have not shown any code here, unfortunately. Maybe they did not design the examples clearly. They have not designed the examples clearly, so yeah. But maybe they have in their source code here. Yeah, they do have these examples, right? If we go to complete MySQL, if you want to set up a MySQL one, you can import this module. And then you can see engine is MySQL, engine version is 8.0, major version is 8.0, instance class is dbt4g large. An identifier is something else, right? So yeah, this is how you can use your models. And that's all I wanted to show you. Maybe there are other sources also. For example, we looked at local paths and Terraform registry. If you put something in Git, for example, then you go to Git and you can pass the Git URL, right? If you store something on GitHub, then you can pass the GitHub URL, of course. And you can also use Mercurial repository. You can use anywhere if it is stored on HTTP, right? So if it is somewhere running on HTTP, you can just provide the path and say name is this one, right? Something like this. Okay. Then you can also put them on S3 bucket and then just give the URL for S3. That is also point, or the Google Cloud Storage bucket. Right. So this is how you can use modules. You can also develop your own module. You can write your own module, upload on GitHub, and then just say, well, give the GitHub URL, something like we have seen here. So upload your module on GitHub like this, like these guys have done, and just say, well, use my module like this, and it should be done. Or you can create an account on the registry using GitHub maybe, and then publish your module here. Right? So you can sign in and publish your module on Terraform registry as well. That is also quite possible. Okay, that is all I had for you guys today. Any questions? I can take some questions now. I'm looking at the chat window. I'm not sure if there is any Q&A, which I might be missing. I don't see any questions on the chat window. Is there a limit on the instance created using Terraform? The limit is based on your AWS account. Terraform does not enforce any limits. Does Terraform use CloudFormation in the backend? No. In the backend, it uses the REST APIs exposed by the cloud provider. It does not interact with CloudFormation at all. Any more questions? Keep them coming, guys. We still have some time. Is there a way to version control and store that? What are you referring to for storing? Terraform is not open source anymore. It used to be, but it is free to use. Vinay, I'm waiting for more explanation on a question. Store the versions, data similar to CloudFormation stack, like resource events and all. It stores whatever resources it creates locally. Yeah. Something similar to stack is a workspace in Terraform. So when you create resources, they all are bound to a workspace, and you can create new workspaces and create new set of resources. So yeah, that is also possible. Can you list open source alternatives of Terraform? So Terraform is, well, first of all, it should not be a concern if you have a Terraform because it is free to use. But at the time when Terraform announced that they are not open source anymore, there was a fork of Terraform that was created. Right? So Terraform fork, let's say it's called Open Tofu. Right? So Open Tofu is like Terraform, but it is open source. Okay. There is Pulumi. Let's see, Pulumi. I haven't used Pulumi much, so I can't comment about it. Okay, yeah. So, yeah, there might be Pulumi also. You can use Pulumi, but then you need to know programming language, right? So Go or Python. And I'm not sure how they manage state and all. Cool. All right. Any more questions? What are the programming languages supported by Terraform? Again, they're not programming languages. It's just configuration, right? So whatever code we have written is configuration. So you can write any markup language. Like you can use only two. One is HCL, which is HashiCorp configuration language, which you see in front of you. And another option is to use JSON in Terraform, but nobody uses it. It's not as convenient and quick as HCL. All right, so looks like the questions have dried out. Thank you for your time. Hey, okay, there's a question. We have to set up all things at one go, or we can do it as per requirement. First, we create VPC, and then as per requirement, we add the routes. Yes. So you can go from top level to bottom level, right? That's a very good question. How should you write the resources in Terraform? So it should be always top to bottom. For example, let's say you want to create an AWS instance, right? And when you create an AWS instance or EC2 instance, to connect to the EC2 instance, you need security group, you need AMI, you need a key pair, right? You want to connect it to a subnet, right? So make sure that you have an AMI ready, you have a security group ready, you have a key pair ready, and you have a subnet ready before you create an instance. Now, to create a subnet, you may need a VPC, right? So before you create a subnet, you create a VPC. Similarly, for security group, before creating security group, you should create a VPC because security group is created in a VPC, right? So it all depends on top to bottom. Always create the top level resource in the hierarchy first. So first create a VPC. Then when you are creating subnet, provide that VPC's information. Similarly, when you are creating a security group, provide that VPC's information. Then you create an AMI. Maybe you do it some other way. You create a key pair. Then finally, you create an instance. And in the instance, we specify everything else. So this is how you should go always. I hope it makes sense. All right. Thank you, guys. Thank you so much for your time. And I am going to see you around in the next webinars. Thank you for joining. Have a good day and have a good week as well. Thank you. Have fun. Bye.